All right, so here we are onto the sixth part. Let's see, that's just about 20 minutes worth of video so far. Okay, so I just mean on the first 5 videos, it's been about 20 minutes. All right, so we're switching gears here. We're switching gears from talking about strong acids to now talking about weak acids. By definition, a strong acid is one that 100% dissociates or 100% ionizes, whereas a weak acid is something that is basically only about 1% ionized. Now, that's our definition, that's our division. Strong acid totally dissociates, weak acid only partially dissociates. Now, one thing that's always important to remember is that this is on a spectrum. So are there weak acids that are stronger than others? Absolutely. There are some weak acids that are about 2% ionized, 3% ionized, 5% ionized. But think about this as it's all dissociation, in which case you're talking about a strong acid, or partial, in which case you're talking about a weak acid. Okay. Now, moving forward from there, we have something that we use to kind of understand the level of dissociation. That is a weak acid equilibria, or a Ka. Now, there's no value that you have to remember about this. There are some trends, which we'll see in just a moment, but remember, the only constant that I want you to be familiar with or to have committed to memory is that Kw. Kw is equal to 1 times 10 to the negative 14th. Now, what a Ka is basically looking at a acid dissociation, or Ha going to H plus A minus, with H, your hydrogen ion concentration, and A minus as your products, and Ha as your reactants. So just like whenever we look at an equilibrium expression, concentration of our products divided by concentration of our reactants, we set it up in that way. Now, here we've got it written in two different ways, where we use a hydronium ion, or where we just look at the hydronium ion equivalent to a hydrogen ion, in which case, there's your two expressions. Okay. Now, the magnitude or the size of a Ka is going to be important because of the fact that a larger Ka means that more ions have ionized or dissociated. A larger Ka is indicative of a stronger acid. A smaller Ka, more molecules are associated, so more of the H and A remain intact. What that means is that you're dealing with a weaker acid. Excuse me. Now, we can look at acids and Kas, and we can look at something known as, or something referred to as, our percent ionization. Now, our percent ionization is going to be the concentration of our ionized form versus our original concentration. Multiply that by 100, we get a concentration, or we get a percentage. Hydrogen ion concentration at equilibrium versus our Ha initial concentration. That is going to be multiplied by 100. That's a measure of our percent ionization. The larger percent ionization, the larger the Ka, so a stronger acid. The smaller percent ionization, smaller Ka, therefore a weaker acid. Okay, so it's important to know these trends for Kas. Larger Ka, stronger acid, smaller Ka, weaker acid.